Hello, today I'll be going over the RAN GTPase cycle. What this cycle is basically a way for proteins to be imported or exported out of the nucleus. Normally, proteins that are smaller than 60 kilodaltons can passively diffuse through the nucleus by the nuclear pores. However, if the protein is bigger than 60 kilodaltons, they must go through active transport. Now, there's two variations to this, but the first one we'll be going over is the import, which uses important. Now, there's two proteins here. The first one is RAN-GDP, which stands for guanosine diphosphate, which is why there's two phosphate groups. There's also important that's bound to NLS, which is a nuclear localization signal, and this is on the target protein that we want to bring inside the nucleus. For the first step, both of these proteins enter the nucleus. And RAN-GDP gets acted on by a protein called RCC1. And what RCC1 does, it adds a phosphate group to RAN-GDP, turning it into RAN-GTP. And it's GTP because it's now triphosphate instead of the diphosphate on RAN-GDP. Important is also within the nucleus now. And RAN-GDP binds to important, which also has the nuclear localization signal. Which also has a target protein. However, once RAN-GDP binds to important, this NLS actually comes off. It comes off and it stays in the nucleus, and this is essentially how the protein gets into the nucleus. Now, after this, RAN-GDP and important exit into the cytosol. And they get acted on by two additional proteins. They are called RAN-GAP and RAN-BP. And what these proteins do is it kicks off a phosphate from RAN-GDP turning into RAN-GDP. By doing so, it also changes the conformation, and important is now no longer binding to it. Important comes off, and it can repeat this cycle, bringing more proteins into the nucleus. Now that's for import. There's also a second variation for export, and what we start off with is RAN-GDP bound to exportin. Now, if you remember, importin is the protein for the import, but very similarly, exportin is the protein for exports, and is also bound to a protein that wants to leave the nucleus. It is called NES, which is the nuclear export signal, and this is bound to the target protein that wants to leave the nucleus. Now, this complex will leave the nucleus, and very similar to the import cycle, it also gets acted on by RAN-GAP and RAN-BP. This removes the phosphate group from RAN-GDP, RAN-GTP, and turns it into RAN-GDP. By doing so, it also kicks off exportin, and now you're left with RAN-GDP and exportin. These two can re-enter the nucleus. And also, for when the exportin has NES, when RAND GDP turns into RAND GDP, it also kicks off exportin, and NES also comes off. And this is how the protein ends up into the cytosol, out from the nucleus. But RAND GDP also gets acted on by RCC1, and this is how it turns back into RAND GDP. And exportin is also back in the nucleus, and it can bind to another NES or a target protein that wants to leave the nucleus. And for both of these cycles, they're very similar, but obviously the main difference is where on the target protein importin or exportin binds to, and that's mainly it.